all day today on this one, and it's because you haven't seen it before. People have been saying both sides are the same. But I have to teach you something that maybe you haven't seen before. On the left side, when it looks like this means negative 5
Times negative 5.
squared, okay? Which is 25. It means negative 5 times negative 5, which is 25. On the right side of that inequality, that right here, that is not negative 5 squared. It looks like negative 5 squared, but it is the opposite.
Really?
I know, of 5 squared.
Is it just 5 squared times -1?
It is like a 5 squared times negative 1. So this is actually the opposite of 5 times 5, which is negative 25.
I said false.
So this is actually true. Now let me go over this again because it's very nuanced. I agree. I see where you're coming from. This looks like a negative 5. This looks like a negative 5. But we need a way in mathematics to differentiate. And in this case, this is a negative 5. It's all nice and cozy in those parentheses. This is the opposite of 5. And it's kind of related, so when we get to exponential functions and quadratics, it's kind of related to the order of operations. This 5, just the 5, needs to be raised to the second power first. So that's why this pumps out a negative 25, and this pumps out a positive 25. This is the negative 5. This is the opposite of 5 squared. I get that they both look like it, but this is a thing that's in math you need to know kind of thing, all right? So that's why I'm pointing it out. It's tricky. When I got pretty good at this is when I focused on the words, actually. I remember it being like, dang, it looks like a negative 5, man. Well, it's the opposite of 5 squared versus negative 5 squared. So when you can identify and focus on the words, then we'll get it right more often. But it's a thing I show every year, and it's a thing kids seem to struggle on as it shows up over and over every year. Again, if you can get to the words and base it on concept, we're less likely to mess it up later. All right, so filling this out. We got 2 cubed is 8. 2 squared is 4. 2 to the first is 2. What keeps happening in my answers? Yeah, so I'm multiplying by half over and over or dividing by 2, right? So as I go down an exponent again, I'm dividing by 2. What's 2 divided by 2? I'll get there. What's 2 divided by 2? 1. So there's that 0 power again. We proved it with like all the exponent rules. And then right here, the next exponent down. Now we're at the 1/2. What happened? My exponents were going 3, 2, 1, 0. Negative 1. There's a pattern there. So like, even if you're still not to like, being 100% what's going on here, we can extend we could just sit here and keep extending the pattern, right? And so divide by 2 again. 1/2 divided by 2 is 1/4. Divided by 2 is 1/8. Divided by 2 is 1/16. So Ivy, what was your question?
Well, I was just like, the multiplier is 1/2.
Yeah.
Is 2 to the 4th power multiplied by 1/2? Isn't that like 2 squared?
We can talk about that. So 2 to the 4th power times 1/2. Really what I have there is 4 factors of 2 in the numerator, 1 factor of 2 in the denominator. It'd cancel 1 factor of 2. Right? This would be 2 cubed. I can show you here. 2 to the 4th is 2 times 2 times 2 times 2. 1/2, if I multiply by half, it'd give me a 2 in the denominator, right? Divide by 2. That cancels 1 factor of 2. I'd still be left with 3. Yep. Cool.
Excuse me, pardon.
So,
Oh, yeah.
who can help me find the pattern for 2 to the negative 6 then? Because that's not just the next one down the line. What would 2 to the negative 6 be equal to? Lily? 1/64th. Or, I might take 1 over 2 to the 6th, similar. It's the same thing, but yeah, 1/64th. Notice, even though we're not base 10 anymore, all of my exponents, even though they're negative, are they pumping out negative answers?
Nope.
No, so I'm going to say this a million times. Negative exponents have nothing to do with positive or negative. 0, zilch, nada. The only way exponents make something negative is if you have a negative base with an odd number of exponents. So who can help me write 1/32 as a power of 2? So 2 to the what? To get to 1/32. Ryan? 2 to the negative 5. So that's 2, 4, 8, 16, 32.
Well, if 2 to
Awesome.
the negative 6 is 160.
So the reason this works, again, is, what does a negative exponent mean?
Fraction.
It doesn't mean fraction.
Decimal.
Doesn't mean decimal necessarily. Reciprocal. Because if I threw a negative exponent on a fraction, it'd flip it still, right? So it could be more than 1. It could... So what's the value of 2 to the 0 power?
1.
1. We kind of established the 0 power several times.
Anything to
Who can help me write 5 to the negative 3 as a fraction? All right, Vinny, what do you got?
5 to the negative 3.
Yeah, how do I write that as a fraction? What does a negative exponent mean, Vinny? Reciprocal. So what's the reciprocal of 5? That'd be the opposite of 5. The reciprocal of 5 is flipped.
Oh, it would be
1/5.
1/5.
So, but that 5's to the 3rd power. So instead of 1/5, I got 1 over.
No, 1 over 50.
It's not 5 times 3. It's 5 times 5 times 5.
Oh, yeah. So
Good mistake.
120. I don't know.
5 times 5 is 25. 5 quarters is $1.25. 125. I like thinking quarters with 25s. Anybody else? No?
Yeah.
I'm alone.
I always-
Okay, so who can help me write 3 to the negative 4 as a fraction then? Maddie?
180.
180 first. 3 to the 4th is 81. The reciprocal of that is 1 over 81. So, big idea from all this, because we did this all with tens. Did changing the base change the rule? Or what the exponent does? Did changing the base change the rule at all? No. Negative exponents are still reciprocal. So, why did we start with tens, do you think?
Because they're easiest.
It's easiest. We're moving decimals. We know tenths, hundredths, thousands. So we start with the tens. Also, the tens worked nice with geometry, right? When we wanted the cube, we could do like 10 squared times 10 squared to get to the million and stuff like that. So what we just established here is those same principles, all the exponent principles, they all work with all things with the same base, okay? That's what we just established. So that's what's on the next page of your slides. Right here. Pretty much, regardless of the base, the same principles apply. It's all because there's like that many factors of something that you can combine or cancel. So on this portion, you and the person you're with, that I buddied you up with today, you're going to pick 2 of these lists to find the thing that doesn't match the given. Okay, so actually, I'm going to change this. I'm going to do number 1 with you guys. You guys are going to pick another one.
Okay.
Just to save a little time. So, because I want to give you the approach. I had a lot of people trying to use calculators and then do computation. Don't do that. We're going to focus on concept. So, when I have a power to a power, it's saying I have this thing inside over and over, right? What's repeated addition? Multiplication. So when I have a power to a power, what do I do?
Multiplication.
So this is 5 to the negative 9. So does it fit?
Yes.
Yes, okay. What about negative 5 to the 9th? Is that the same thing? No. The base is a negative 5 instead. And then remember, what is the only thing the negative exponent means? What does a negative exponent mean? Not opposite, reciprocal. Opposite would be like negative becomes positive, okay? So reciprocal, we flip it. So looking at the quotient. Remember when we were doing the quotient, we were looking for common factors to cancel each other? What operation is canceling? Subtraction. So there's 2 ways to think about this one. We can think of 5 to the negative 6 minus 3, which is 5 to the negative 9. I personally think of this as this becomes a positive exponent by taking the reciprocal. And then I have 9 factors of 5 in the denominator, which is 5 to the negative 9. It's like the same thing, but that's just what my brain does. It makes negative exponents positive first. Okay, we already established power to a power, we multiply. So does 5 to the negative 6 work? Nope, so that one's out. And then this one, you could do the subtraction. We could do 5 to the negative 4 minus negative 5, which is 5 to the 1. I prefer to think of it like this. To get my positive exponents, I take the reciprocal of both. And 4 of these cancel 4 of these. That's my preferred. So that's out. That doesn't work.
Nope.
And then this last one. This is just, I have 4 of them and 5 of them, reciprocal, right? So that's 5 to the negative 9. That one does work. So, because I have 4 factors of 5 reciprocal, I have 5 factors of 5 reciprocal, that's a total of 9 factors of 5 reciprocal. Really young. What are the operations we could do with these exponents? Right here, what did we do with them? We added them.
Add and then
What did we do here? Subtracted them. What did we do here? We multiplied. And then we know reciprocal means flip. There's not a lot of things, like any of those things, we're adding, subtracting, multiplying small numbers. Not hard, right? If you're focused on rules, it's going to be hard to know what to do when. If you're focused on concept to bring you to the rule, some people are going to breeze. I'm telling you, from the other classes today, some people breeze through this and other people are like, The people that breeze through it have been the people focused on concept the whole time. Okay? The people that are getting stuck are the people that have been leaning on memorization. But so we still, even if you're feeling stuck, what do we focus on today still? Not memorization. We focus on concept, okay? So, pick, you and your table, pick one other set, but it has to be from set 2 or 3. You and your partner, pick a set 2 or 3 to try to see if the number's the same. All right, y'all, let's roll through these 5s. 5 factors of 3 and 2 factors of 3 are 7 factors of 3. So that one doesn't work. When I have 5 factors of 3 twice for a total of 10 factors of 3, that one does work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that one does work. This one's fun. The negative 10 means reciprocal, right? So I take the reciprocal, it's 3 to the 10th. So that one is working. 7 factors of 3 and 3 factors of 3 for a total of 10 factors of 3. That one works. 10 of these cancel 10 of those for 3 to the 10th. That one works. And 2 of these cancel 2 of these for 3 to the 18th. That one does not work. We good?
we are good, Mr. Mac.
All right. Let's get through these next 2. Oh, new color, new color. Ooh, this one. This one's called cyan. Is that what it is? Cyan. 4 cancel 4. I'm left with 4. That one checks out. 4 factors of x for 4. Okay. This one's fun. I like an intermediate step here. I like to think of this one as x to the 8th over x to the 4th, which is x to the 4th. You could do negative 4 minus negative 8. It still works. But I like to make a positive first. So this one's going to be x to the negative 12. So this one doesn't work. You can do negative 4 minus 8. What I do is I imagine this, it's going to be in the basement with 8 for 12 in the basement. That's a negative 12. X squared squared, x to the 4th. 4x is 4x, so that's not x to the 4th. And 3 factors of x and 1 factor of x is x to the 4th.
Mr. Mac, is the x negative 12, is that?
That's not, oh yeah, that one's out. I just forgot to cross it off.
Because it's not x times 4. Right? It's not.
And number 4. I didn't let you pick number 4 because it's the easiest of them. Is 8 to the 0 is equal to what? 1. So it's 1, 1? Yeah. Is 0, 1? No. If I add these together, I get 8 to the 0. That is 1. Well, don't cross it off that good.
Actually,
Anything divided by itself is 1. 10 to the 0? 1. 11 to the 0? 1. Okay, cool.
anything to 0?
That's it. Big picture. Big picture.
Anything to 0 is 1, right? Yes, ma'am.
The same exponent rules we've developed from concept for tens work for all the other numbers.
Why does your shape I use as the same as the other?